Hi, how are you, dear student? Here I am, Mr. Cyrus again, and in today's our lesson, we will continue the new chapter with the chapter 7. In the section 7.1, we will continue with the section 7.1 about the circuit rule. Yes, it is, and it's good to be with you again, and thank you very much. Let's just start our lesson. Dear student, what is our lesson goal for today? In this lesson, you will learn to derive using the Kirchhoff's law, the formula for the combining resistance of two or more resistors in series and in parallel, and solve the problem using the formula for the combined resistance of two or more resistors in series and in parallel, and applying the Kirchhoff's law to solve simple circuit problem. And recall that rate of heat transfer in the resistor is equal to I square multiplied by the resistor. Dear student, you know what, when we have any electric circuit, we have some rules for the electric circuits. For example, we have some rules for the current and we have some rules for the potential difference, how they will act inside of the electric circuit. That's why in this one now we will start with the currents rules. And the first rule that we have is called the Kirchhoff's first law. In the Kirchhoff's first law, which is about the current rule inside of the electric circuit, it's telling you that at any junction in circuit, the total current leaving the junction is equal to the total current entering the junction. What does it mean? It means that, for example, we have a junction like this one here. Here we have the junction, and this junction, for example, we have three wire. These three wire are connected in this junction. It means that now we can say the junction here is the connecting point of these three wires. If you look at these three wires, what you will see, in this wire we have 0.5 ampere of current that pass through this wire, and here and the direction of the current is into the junction. It means that it's flow in the junction. And if you look at the wire 2, you will see the amount of current that is passing through this wire is equal to 1.5 ampere. But if you look at the direction of the current, it is flow out the junction, dear student. And according to the Kirchhoff's first rule, is saying that the total amount of the current that is entering the junction is equal to the total amount of current that flow out the junction or leaving the junction. If you see that this one is entering the junction and this one we don't know, but if you look at the total, which is through leave the junction, is equal to 1.5 ampere. Here we have 0.5. It means 0.5 plus 1 ampere, the wire 3, the amount of current that passing through this wire must be equal to how much? 1 ampere. Why? Because 1 ampere plus 0.5 ampere is equal to 1.5 ampere. It means that the total amount of the current that is entering to the junction is equal to the total amount of current that leaving the junction. This is about the Kirchhoff's first rule, about the Kirchhoff's first law about the current rule in the junction, dear student. And dear student, let me to tell you one thing, that this Kirchhoff's first law is also known as the junction rule. It is also known as the junction rule. Dear student, and according to the Kirchhoff's law, Kirchhoff's first law, it is following the conservation of charge. It follows the conservation of the charge. Why? Because as you see that the current, the amount of the current that is entering the junction, what does mean current? Current, as we studied before, dear student, we said that the current is the charge flowing per second, or the charge flowing in the unit of time. Charge flowing in the unit of time. It means that when the current is entering the junction, nothing will happen to the charge carrier when they are close to the junction. That's why we are naming the Kirchhoff's first rule, or the Kirchhoff's first law follows from the conservation of charge. That's very important. And we said that the Kirchhoff's first rule is also known as the junction rule. Dear student, let me to remind you one thing before going to the electric circuit. As we studied before, we said we have two types of electric circuit. We have the series circuit and we have the parallel circuit. what is the series circuit and what is the parallel circuit. If you look at these two pictures, you can see and you can understand easily. For example, if you look at this picture, this electric circuit, this is the simple electric circuit that is consists of three main parts. We have the battery, wire, and the user, or the lamp, we say. We can say we have the lamp. This three, and inside of this electric circuit, we have more than two components. We have more than two components. For example, we have three bulbs here. These three bulbs are connected with each other in a series. What does it mean in series? It means they are making one path for flowing current inside of the circuit. They are making one single path for the flowing current. But in the parallel is different. In the parallel, between each two components, we have the junction, dear student. Between each two components, we have the junction. One junction here, another is here, another is here. It means that when they are making different paths for following the current inside of the circuit. Now, this circuit is the parallel circuit, which is consists of the three main parts: battery, source, we can say, wire, and the lamp. But inside of this circuit, we have more than one component. Dear student, let me to tell you one thing, that how electric circuit is working. For example, dear student, this one, we are familiar with this one. For example, here we have the pump of water. If you want to take out the water inside of the wall, what you will do, you are using the pump, and the pump, and we have the pipe which is connected to the pump, and we have the container, which is we are storing the water. Look, these three parts are connected with each other. We have the pump, pipe, and container, or user. Dear student, inside of the pipe, what's flowing in? The water is flow. True? The water is flowing, and it will connect it to the user. Electric circuit is the same idea. We can say the pump is the battery or the source of the current, and this battery is connected to the wire, and the wire is connected to the lamp, to the user, we can say. Inside of the wire, just like the pipe, and here instead the electrons flow. Look, inside of the wire, electrons are flow. In the pipe, inside of the pipe, we said that the water is flow. Inside of the wire, we said that the electrons are flow. This is just for like to understanding about the electric circuit, dear student. Now, we have some components in the circuit. As we know that we have the 8 main components in electric circuits, and we studied before and with the function of each of them. Now, for example, now still we are talking about the current rules. What is the current rule if in a series circuit? When the current entering the component is the same as the current leaving the component. Dear student, we have the series circuit, as you see. When the current is entering to the component, it's the same when the current is leaving the component. Even we have more than 2 components, it's normal. It will be the same. It will be the same. The second rule is the current passing through 2 or more components in the series is the same through each component, dear student. What does it mean? It means that the amount of the current that comes from the source is equal to the same amount that cross of each component, dear student. It means the amount of the current that passing through that passing through this component is equal to the amount of current that pass through this component, and is equal to the amount of current that pass through this component. That's why for the amount of current we can use this formula, dear student. The total amount of current is equal to the total amount, the current that passed through the lamp 1, and is equal to the amount of current that through this component is equal to the amount of current that pass through this one. This is about the components, the current rule when we have more than 2 components inside of the electric circuit in series. Dear student, here we put, for example, this light indicators. This one we have light indicators. For example, we have the bulb. If we have any other components like the resistor, like the capacitor, any of them, if we have them in the electric circuit in series. We are applying the same rule for the current. Now, this is now what we have. We have one more thing about the potential difference rule. We finished the current rules. Now the potential difference rules. What is the potential difference rule in series circuit and electric circuit and in the parallel circuit? Dear student, if you remember that we said that the potential difference is what is the energy transfer in the unit of charge, or in the unit of charge, the energy transfer per unit of charge, per unit of charge. But the potential difference of voltage between any 2 points in circuit, between any 2 points in circuit, is defined as the energy transfer per coulomb or per charge that follows from one point to another. This is the main idea. You have to know very well, and please write down this one. It's very, very interesting. In electric circuit, the potential difference is the energy transfer per charge from one point to another point. From one point to another point. Now here we have two rules. We have one rule in series, we have one rule in the parallel circuit. Dear student, for two or more components in series, the total potential difference, for example, we have this electric circuit, and this electric circuit is connected. You have three components. The resistors are here, and these three resistors are connected with each other in series. And the total, when we have two or more components inside of the series circuit, the total potential difference is equal to the summation of the potential difference across each component. For example, if you find the total potential difference of this circuit, we will say delta V is equal to the potential difference that cross to this one, this component, plus the potential difference that cross to this one, and is plus the potential difference that cross to this one. That's why we are saying the summation. It means that we will add the potential difference of each component. Delta V is equal to delta V1 plus delta V2 plus delta V3. But the potential difference across components in parallel is the same. Here we have the same circuit, but this circuit is connected in parallel. Here we have three components. These three components, we have the variable resistor and we have the resistor. They are connected with each other in series, in parallel, I'm sorry. They are connected with each other in series, and the potential difference in this circuit is equal to the potential difference in the parallel circuit is the same at any components. For example, the amount of the potential difference in this resistor is equal to the amount of potential difference in this one, and this one is equal to the amount of the potential difference for this one. That's why we are saying delta V is equal to delta V1 plus delta V2 plus delta V3. It means they have the same potential difference for each resistor. Now, in the section 2, dear student, if you look at your book, in the section 2, we have the resistors, and we will study more about the resistors. But we have the same thing. We have the resistors in parallel, and we have the resistors in the series circuit. Now, what we will do, now we will start with the resistors in series circuit. Our series circuit describes two or more components of a circuit that provide a single path for the current. In series circuit, we said before, they are giving the single path for the current. They are providing the single path, and the resistors in series carry the same current. For example, when we have the series circuit, the amount of the current, it will be the same. For example, if you look at the circuit, the amount of the current that cross this component or this resistor is equal to the amount of this one, and is equal to the amount of this one, and is equal to the amount of this one. That's why we are saying that the total current is equal to current 1. It means that the amount of current that cross to the resistor 1 and equal to the amount of the current that cross to the resistor 2, and is equal to the amount of the current that cross to the resistor 3. But the only thing the difference, as we said before this one, the potential difference in the series circuit is different, dear student. The total amount of the potential difference, we will take the summation of them. We studied this one before, but this is the new thing for us. Dear student, how we can find the resistors in the equivalent? Dear student, the equivalent resistance in series circuit is the sum of the circuit's resistance. The equivalent resistance in a series circuit is the sum of the circuit's resistance. For example, if you find the total resistance of the circuit, what you will do it? You will just add them the resistance of each component, dear student. The resistance of each component. For example, R1 plus R2 plus R3. How many resistance we have, you will just add them in series. But in parallel is different, dear student. In parallel, the resistors in parallel have the same potential difference. Look, in parallel, the resistors in parallel have the same potential difference, but if you want to find the total current in the parallel circuit, what you will do it? We will just add them. You will take the summation. You will take the summation of the current in parallel resistors. In parallel resistors. And how we can find the equivalent resistance? Equivalent resistance, dear student. The equivalent resistance is equal to 1 over 2 R1, 1 over plus 1 over 2 R2 plus 1 over 2 R3. Why? Because the equivalent resistance of the resistors in the parallel can be calculated by using the reciprocal relationship. This relationship is called the reciprocal relationship, dear student. Reciprocal relationship. Yes. Here we have the parallel circuit. This parallel circuit is connected. We have more than 2 resistors, and we can find the current for each resistance. We can find the total current in this circuit by taking the summation of all amount of the current that cross for each of the resistance, and the total potential difference is the same for all of them. Now, dear student, let us to understand about the combination of the resistance. Combination of the resistance. For example, here we have what? We have 2 resistance here. Resistance 1, resistance 2, and we have the battery. And if you sketch the diagram, this one, you have the symbol of battery, the symbol of the resistance, as you see. Now we are connecting the circuit. Now the circuit is connected. The battery connected to these 2 resistance, and here we have the diagram, and this is called the simple circuit, dear student. The simple circuit, as I told you before, the simple circuit consists of what? 3 things: source, wire, and the resistance. Now what we will do it, dear student, when here we have the potential difference, the voltage, because of the battery, and the current is flowing inside of the wire to the resistance. It means that the current will cross through each of these 2 resistance. In this case, how we can calculate them? As I told you, in series, the current in the series circuit, the amount of the current is the same. For example, the current that throw in this resistance is equal to the amount of the current that throw in this resistance, and is equal to the total. Same. But how we can find the potential difference for this one? By connecting with the voltmeter. Here we have the voltmeter. When you connect the voltmeter with this resistance, in this case it will read the amount of the voltage that cross to this in this resistance. We can measure the voltage or the potential difference in this resistance by using the voltmeter. For this one is the same. We will calculate the potential difference because, dear student, as I told you, in the series circuit, the potential difference is not the same. We will say that if you want to calculate the potential difference of the total of the circuit, we have to add them. You have to find them. Potential difference for this resistance plus potential difference for this resistance. How we can find it? Sometimes we are using the connecting by the voltmeter, or by the calculation. Sometimes it will give you the current and it will give you the amount of the resistance that we have, the resistivity of the resistance, and you can calculate by using the Ohm's law. Yes, the Ohm's law is equal to what? Ohm's law. This is the Ohm's law. The resistance is equal to potential difference divided by current. We can find the voltage for this one. Now, if you know the value of the resistance and if you know the value of current, you can find the voltage or potential difference easily. For this one is the same. We are applying this formula, and the total, dear student, the total, we said that in series, how we can find the resistance? The resistance is equal to R equivalent is equal to R1 plus R2. True? Yes. And here we have the total. If you, dear student, now this is we make this simple circuit, dear student. This circuit, it was complex circuit. We had two more components inside of the circuit, and both of them are the resistance, and we combined each other, these two resistance, in this way. When you are combining these two resistance, we are calling them R equivalent. It means that we are using this formula. Again, we apply the Ohm's law. Yes, we said that if you find the R equivalent, you will find in this way. You will add them in series. Now, let us solve this question, dear student. What we have three resistors. The resistor 1 is equal to 1 ohm. The resistor 2 is equal to 2 ohm. And the resistor 3 is equal to 3 ohm. These three resistors are connected in series, dear student. Look, these three resistors are connected in series under the voltage of 9 volt. Potential difference is equal to 9 volt. Now, find the main current, IM, it means the total current of the circuit, and what else? Find the voltage of each resistance, resistance, potential difference of these three circuits, dear student. Now, what you will do? If you want to find the main current, what the main current is? It means that we have to find the total current that inside of this circuit. How we can find it? Dear student, as you know that in the current, in the series circuit, we said that the potential difference will be the same for each of them, for each of these three resistors. But for the current, or for the resistance, I'm sorry, we said we will add we will add them. We will take the summation. For example, if you want to find the main current, IM is equal to potential difference divided by R equivalent according to the Ohm's law. Now, we have the voltage, potential difference, and we have the R equivalent. We are looking for this one. Okay, potential difference for the total circuit is equal to, it will be the same, 9 voltage. But the R equivalent, you will take the summation of them. Now, 1 plus 2 plus 3 is equal to 3. 1 plus 2 is equal to 3. 3 plus 3 is equal to 6. Now, 9 divided by 6 is equal to 1.5 ampere. Now, the main current is equal to 1.5. 1.5. Now, this, dear student, this is, here we did the mistake here. This potential difference is the potential difference from the battery, and the potential difference is not the same for this resistor and this resistor and this one and this one. It will be different, but the current we said is the same. In series, the current, it will be the same for each of them. Now, how the B voltage for each resistor. Now we have to find the V1 for the resistor 1. Now we have to find the V2 for the resistor 2. Now we have to find the resistor potential V3 for the resistor 3. Dear student, V1 is equal to what? I1 multiplied by R1. R1 is equal to how much? 1. I1 is equal to Im is equal to 1.5. That's why 1.5 multiplied by 1 is equal to 1.5 voltage. It means that the potential difference in this one is equal to how much? 1.5. For this one is the same, dear student. This is how we can calculate the potential difference. Now, if you want to find the potential, the total one, for example, 1.5 plus 4.5 plus 3 is equal to 9. It means 9 is equal to 9. It means that the potential, that's why 9 voltage is equal to 9 voltage, dear student. In parallel circuit is the same, dear student. We have these two circuits. Again, we have these two circuits. We have this circuit. These two resistors are connected with each other in parallel. And again, we are saying we have to find the voltage in each resistance by using the voltmeter. And we said that the potential difference in parallel circuit is the same at any in each component. The potential difference is the same, and the amount of the current, we will make the summation of them. And again, for finding the resistance of each of them, we are applying the Ohm's law again, because Ohm's law is equal to R is equal to potential difference by the current. We are applying this one. And if you want to find the total, and we, dear student, look, we said that we have two things. Potential difference in the parallel circuit is the same. We will take the summation of the current. And if you find the RQ, what does it mean, RQ? R equivalent, or the resistance, I mean. We are using this formula in parallel. We studied this one. If you find the resistance of the circuit in parallel circuit, we are using this formula. And here we have an example. You can do it by yourself, this one. And we got, because dear student, look, we studied this one, but I just give you as a summary. This is a whole about the circuit rules, and we explain it and we solve the example. And this is your homework. Thank you very much, dear student. Thank you.